So this video will focus on only one thing, and that it's factoring with three-term or trinomial quadratic expression. Okay, so now before we start, any of the questions, I have some prerequisites I want to lay it out. Number one, open your eyes. Okay, make sure that you are looking, make sure that you are reading. Okay, now what I mean by looking and reading, now you got to have some number sense. Okay, some good number sense right there. All right, so if you see anything that happens as a pattern, then it should catch your attention. Okay, and say, oh, you know what? I can see something similar. For example, if you just take a quick look at number two, all right, I give you 5 seconds. Can you see something in common? Okay. Now, and the reason why I'm asking this question, can you see something in common, is because a lot of students, they kind of, drill these quadratic factoring, and then what's going to happen? What's going to happen is that there are some very obvious hints. They just miss them because they just go by the book. All right, they go by the procedure. Now, and here's another thing that I want to make clear. Okay, the kind of factoring that I will be going over through this video, or this couple of videos, is that is something that you will continue to use for your future courses: Algebra 2, Pre-Calculus, and of course, Calculus. Okay, it's a little fundamental skill, as fundamental as, multiplication table, adding fractions, so on and so forth. Okay, so what I mean by opening your eyes, well, I hope you can see that all three terms got at least one K in it. All right. All right. And then you also see, like, hey, all these numbers, these three numbers, there's some kind of pattern right here. What's the pattern? Well, they're all multiples of 5. All right. So that's kind of a sensitivity that I'm looking for right here, and you need to be very sensitive with these numbers, okay, or these appearances, because that's going to help you a lot as I go through all these in the future. Okay, in the next few minutes. Okay, so number one, open your eyes. Open your eyes. All right, number two. Okay, number two. Well, the next thing that I would like to highlight right here is the word factor. Okay, now factor, it's now I didn't know this when I was a student, because I was just like anybody else in math, in algebra 1 or algebra 2. I followed what the teacher showed me, and then I went by the book, and I could do all the things without knowing what factoring really means, like what the word factor means. So it was until much later that I finally realized that what it means to factor. Okay, so here's a parallel that I want you to see. Okay, I would say, hey, how do you factor the number 12? Okay, and you'd be like, oh yeah, I can do 1 times 12, right? You can also do 2 times 6, right? Okay, of course you can swap these two numbers. You can also do what? 3 times 4. So the very basic meaning of factoring is to say, oh, can you go ahead and find 2 or more things, all right, that would multiply together to give you what? To give you this item. Okay, so you're finding how 2 things could, come together, multiply together, and get you this term. Okay, now, so it's kind of boring, right? You kind of not see the point of factoring until the utility of it. So I want to go ahead and show you something. Why are we doing factoring? Okay, so let me go ahead and bring you to Desmos. All right. So what it's going to happen is this. I'm going to type in y equals to what? I'm going to come up with, I will come up with two random factors, simple factors like x plus 2, and then times x minus 3. So by having these two factors together, all right, so I could gain some very valuable information. Or actually, let me go ahead and do x minus 4. I think that's going to be nicer right here, okay? What kind of useful information that you can get, okay? Because if not, why are we doing factoring? So I'm going to tell you this. By being able to factor, you gain insight of what the graph it's going to look like, all right? What the graph is going to be like. So you are focusing on factoring. Okay, we got the factor. What does it mean? We can graph it. If you see x plus 2 as one of the factors, then we say, oh, you know what? There is a root. There is a root of negative 2, okay? Or you can say, hey, if I know the root it's negative 2, then I know the x-intercept it's negative 2 comma 0. For the second factor, I have x minus 4. So what does it mean? Well, if you have x minus 4, then you know the other root, it's going to be at 4. Well, that's nice, right? That's very nice. All right, that's very nice. And we say, oh yeah, I can also tell that there is an other x-intercept that is 4 comma 0. Okay? Now, how good is this? How good are these two pieces of information? Well, you can graph the roots, right? Now, you can get those 2 points, but what else can you tell? Well, here's one major understanding for quadratic equation or quadratic function, okay? And that is, they're always symmetrical. They're always symmetrical. Symmetrical to where? Well, let's go ahead, slice the graph into 2 halves. Where? Right there. Okay, let me go ahead and make this a little dotted line with the orange. Okay, so you can see like, hey, you know what? That's a line right here, x equals to 1. We call this axis of symmetry. And another thing that you want to know, and we will go more over this in the future, and that is, well, what's a good thing about knowing the axis of symmetry? Well, the vertex, it's always going to be on the axis of symmetry. And this x equals to 1, how do I know it is x equals to 1? Well, guess what? Because of the symmetry, x equals to 1, it's the midpoint or the average between 4 and negative 2. So that's the big picture. All right, but in order to get to this big picture, we say what? We say, hey, let's go ahead, do some factoring. Okay, so that's what we are doing right now. So now, here's another thing. Here are a couple more things that I should go over before we dive into this factoring exercise. Now, there are a couple more things that you need to know, such as, do you know this? Okay, do you know this? Now, if you want to do well, right, if you want to be very sensitive, then I would strongly recommend you to do this. If you find this very foreign and not comfortable, and it is okay, let me go ahead and show you how this happens. Well, first up, what is a plus b squared? Well, the meaning of square is to multiply by itself, right? So what it means, it's simply this, okay? And I believe your teacher probably taught you how to do the foiling, right? The expansion process. And by the way, I've seen a lot of students misusing the word factoring and foiling or expanding, all right? So factor versus expand, all right? So factor, like I said earlier, is to find out the two things or more that would multiply together. You get to the individual items. Okay, so if I say factor 12, you get 1 and 12. You get 2 and 6. You get 3 and 4. Those are the factors you are factoring. If you are expanding, then that's where you talk about the foiling process. Now, I hope your teacher taught you about FOIL, okay? So it stands for first, outer, inner, and last. But I do this a little bit differently, in a different order. I want to do the easy things first. Like what? I want to do the first term, multiplying together. I want to do the last term, multiplying together. Meaning, let's do a times a, which is a squared. Let's do b times b, which is b squared. Okay? They're easy, very easy. Okay? And by the way, it's plus b squared because it's positive b times positive b. And then we'll go ahead and take care of the outer and the inner. Okay? The outer is like this. A times positive b. All right? And then the inner, positive b times positive a, which is also ab. And that's how you get to ab. All right? So that's the proof how a plus b parentheses square, it's a squared plus 2ab plus b squared. Now, knowing this is very valuable because why? I've seen way too many students doing this on whatever assessments they have. They would say, oh, you know what? A plus b squared, it's equal to a squared plus b squared. Okay? So I know what they're thinking. They're thinking like, I thought we can distribute, right? I just follow the rule. Well, that's what happens when you try to memorize math. Well, first, it's not a squared plus b squared. Okay. Number two, how can you tell it's not? Now, that's a key thing. That's a key thing. I didn't know how to prove it until when? Until I realized one very simple philosophy, and that is, if it works for numbers, it works for symbols. If it does not work for numbers, it will not work for symbols. And this is what I mean. For example, okay, let's do this. 2 plus 3 squared. 2 plus 3 parentheses squared, sorry. So you know 2 plus 3 is 5. 5 squared is 25. So we know for sure the answer has got to be 25. Now, if you happened to get tempted to think about it, oh, can I distribute the square? All right, it's fair, okay? We all get tempted. I did. All right, so this is what you do. Try it with numbers, okay? Try it. You'd be like, can I write this? Sure, go ahead, write it and see. 2 squared, it's 4. 3 squared, it's 9. It's going to get 13. Well, but we all know it has to be 25, not 13. And that's how you know the whole idea of distributing, it's wrong. And that was my moment. That was my moment to clearly draw the line, the separation, the little divider, and say, all right, you know what? You know what? When can we distribute? When they are only multiplying or dividing. Okay? When you have this, yeah, go ahead, distribute. And even better is this. Understand the why. You could distribute. Because why? Well, AB squared, it's just AB times AB. And of course, there are two A's multiplying, that's A squared. You have two B multiplying, two B's multiplying, that's B squared. Okay? Same thing over here for the division. Right? What is A over B parentheses square? Well, that's A over B times A over B. Well, guess what? The numerator, it's A times A squared. I'm sorry, I forgot to write the square here. And then the denominator, it's B times B squared. There's always a reason. And too many times, some Algebra 1 teachers, they are only focusing on the answer, focusing on the method, and they did not explain the why, and student would just focus on the repetition of procedure. They had no idea why they got things wrong, like very wrong. Okay, so my purpose here with the videos here is to make sure that you know what is the right thing to do and how you could also know it's not correct. So one more time, all right, if you have A plus B parentheses square, you are always going to get 3 total terms. If you don't, you know you're off, way off, okay? Now, here's another thing, all right? So A minus B parentheses square, what is it? Well, it's going to be A squared minus 2AB plus B squared. Why? You do the same thing that I just did earlier, right here. You can do it. You can see it for yourself. Now, here's one other special expansion that you need to know. And that is a plus b times a minus b. You will see this very often in the future. I promise you. A squared minus b squared. Why? First term, right? A squared. Last, negative b squared. When you actually do your outer and the inner, what you will see is that they would cancel each other out. So that's how we do it. Okay, that's how we do it. So these are so-called special cases. You've got to be very sensitive. Okay, hopefully we'll see some of them here. All right. Now let me give you a few examples so that you know what to look for. Okay. Now, for example, x plus 3 squared. So the thought process is like, hey, what's your a term? Okay, if you just kind of align them together, oh, your a is x. What's your b term? Your b term is 3. So a squared plus 2ab plus b squared. When you do more, you can actually do this in your head and say, oh, hey, that's equal to 6x. Now, let's do one more. Okay, let's do one more. X minus 5. Okay, parentheses squared. A squared minus 2ab plus b squared. Okay? All right. Now, these are not just two random examples. I want to use these two examples to show you one connection. The connection is this. When you look at these numbers, what you realize is that, hey, I think I can see something right here. They're related to 3. How so? 6 is 2 times 3. That's 3 squared. What about these two numbers? Hey, they're related to what? 5. This is 2 times 5. This is 5 squared. That's how you know, like, ooh, it's one of those special cases. That's how we know how to factor, okay? You go forward and you go backward. The more you do, your brain is going to pick up all these patterns, and it's going to be better, way better, okay? So now, if they're not the special cases, we just have to do trial and error, and I'm going to go over those in just a moment, okay? Till next video, we will start working on these numbers.